Hey, good morning, guys. Apologies I'm not there today. I'm not feeling the best. Hopefully, I'll be back tomorrow. If not, should be back on your third lesson. Fingers crossed. Look, today we are going to be going through our next part of our non-linear relationships sort of section. We've now so far, sorry, we've covered all the work on quadratics. Well, most of the work on quadratics. Um, so now we need to move on to a bit more about our functions. So today's lesson is going to be all about functions and function notation. So this is really coming into advanced mathematics for next year, Extension 1, AA, and AI as well. The only one course that probably the function notation doesn't come into is probably Standard 2 mathematics. But nonetheless, still a good thing for us to do. So a couple of things, I guess. First thing today, and remember, please, guys, write some notes down when we're going through this. The first thing I'm going to look at is, I guess, what is a function? Okay, and we see functions all the time. I'm going to also talk about what is a relation. Now, I'm going to start with a relation. We define a relation as a set of any, we call it ordered pairs, we can call them coordinates. Okay, so basically anything is a relation. So you can have a graph, right? And you can literally put a coordinate here, a coordinate up here, a coordinate down here, and a coordinate up here, and a coordinate. That is simply a relation, right? Because you have a whole set of coordinates. There's no set pattern. There's no real graph, I guess, in this instance. I mean, you can make one coming out of that. But certainly it is just a set of coordinates. Now, a function, we define a function as a set of coordinates that only have a one-to-one relationship. Now, that sounds really weird, right? I'm going to say a set of coordinates such that every x only has one y value. That is how we really define a function. Now, I know that at the moment that sounds really quite strange, but if we talk about a graph, right? Let's talk about a parabola. Now, what we're saying there is any x coordinate, let's say I've got an x coordinate there, let's call that, or negative x coordinate, it has simply one y value. We can take another x coordinate here, and it has another y value. I can take another x coordinate here, and it has only one y value. So whenever you have a graph that every x coordinate only has one y value, then you have a function. Now, you might then say, well, what is not a function? Okay, if I look at that relation, for example, if I look at this x coordinate here, can you see how above it we have a y value? If I go below it, we have another y value. That x coordinate has actually two different y values. Now, if we talk about an actual graph that we're looking at in a couple of lessons' time, we talk about a circle, for example. What you'll notice on a circle, at this x coordinate on the right-hand side, it also has a y value on top, but it also has another y value in the bottom. So that particular x coordinate has two different y values. So that we only call a relation. So when it has more than one, we simply call it a relation. It's just a set of ordered pairs or a set of coordinates. If it only has one y value, then it's a function. Now, you might think, okay, that sounds all really confusing, and guess what, guys? It's actually not, because there's a really quick way for us to determine whether we have a function or a relation. We call it the vertical line test. And I'll get you to write that down. The vertical line test is a really quick way to figure out whether you have a function or if it's just a relation. So if it only cuts it once, let's say only cuts the graph once, then it is just a function, or it is a function, should I say. So you can see on that parabola, no matter where I put that vertical line, it only ever cuts that graph in one place. Whereas if I look at the right-hand side in that circle, I can cut it in two places. Now, I know what you might say is, oh, what if I just do it right on the side? So it's a tangent, only cuts it once. That doesn't matter. As long as I can find one place in my graph where I can cut that graph more than once on a vertical line, automatically it cannot be a function. So later on, we'll look at graphs like this. It's a sideways parabola, or we call it y equals x squared. Would you call that a function or just a relation? If I do my vertical line test, it cuts it in two places. Therefore, that is simply a relation. Okay, if I look at a straight line, for example, if I do a vertical line test, anywhere on that straight line, I only cut it once. So we have a function. And I'm going to say most graphs that you deal with this year will be functions. Later on, we're going to look at an exponential curve. Looks like this. You should know that quite well because of COVID. Again, vertical line only cuts it once. No matter where I go, it only ever cuts it once. Therefore, we call this a function. So if it only cuts it once, we have a function. If it cuts it more than once, then we might have a relation. And we can make up all sorts of graphs, you know. We could do one like this and kind of go this and squiggly line, kind of looks like a double parabola or even like a sine curve graph. But again, if I do a vertical line anywhere on that graph, it only ever cuts it once. So it is automatically a function. Again, all you need to find is one place on my graph that it cuts it more than once, and you just have a relation. So again, a function is simply a graph that every x coordinate only has one y coordinate. Okay, and we simply will use a vertical line to test that and to prove that. Perfect. That's a function. So that's the first part of the lesson is what is a function? It's a set of coordinates such that every x value only has one y value. A relation is any set of coordinates, whether it's a function or not. Now, the next part is probably the more complicated aspect of today, but it's actually not that bad. It's just notation. Now, we've looked at things like y equals x squared. We've looked at things like y equals x plus 3. Okay, where these are all equations. I could go even fancier, y equals x squared plus 3x plus 2, for example. Now, we've looked at, I guess, tables of values where you might put some y values and some x values, and then you sub the x's to find the y's. That's how we usually did our linear graphs, and we started to do our quadratics off that table of values. So, for example, you might do an x and a y, and you chuck in -1, 0, 1, and you'd say, okay, -1 squared is 1, 0 squared is 1, 1 squared is, 0, 1 squared is 1. So we did that before, right? And you've done that heaps where you sub the x coordinate in to find the y coordinate. Now, when we talk about function notation, we can write or use function notation to show that in a slightly different way. Now, instead of writing y equals x squared, we write it like this. F of x equals x squared. Now, what that says is the function of x, which realistically is what y is, right, is equal to x squared. So what you will learn is that f of x and y are actually the same thing. Y is f of x. Okay, we just use that as notation because what often we'll want to do is we want to write things like, you know, we want to sub in -1, we want to sub in 0, we want to sub in 1, but we actually want to show that within our actual working. So, for example, if I want to sub in -1, we can say f of -1 equals -1 squared. So we're actually showing within the actual sort of equation what we're subbing into it. And of course, -1 squared we know to be 1. We could say f of 0 equals 0 squared, which we know is 0. F of 1 equals 1 squared equals 1. So all that f of x is, it's just a different way to write our equation y equals x squared. But we use it a lot more in senior mathematics in both AA, AI, Advanced Extension 1. So if I was to rewrite y equals x plus 3 in function notation, we'd write f of x equals x plus 3. That's it. That's function notation. For the last one, we'd write f of x equals x squared plus 3x plus 2. Again, y and f of x are literally the same thing. It is just a different way to write it. Now you might say, well, why would you do that? And later on, you'll see its advantages, because if you want to have two different functions, for example, y equals x plus 3 and y equals x squared plus 3x plus 2, instead of using f of x, we could use a different letter. For example, I could have said f of x, and I could have said g of x. And so now I can clearly talk about the two different functions, really clearly. So if I said, draw f of x, you know which one to draw. You draw the y equals x plus 3. If I said to draw g of x, you know you should draw y equals x squared plus 3x plus 2. If I said draw y, you'd go, well, which one? There's two of them. Okay, so if that's one way to kind of look at it, that we use that notation so we can really be specific between graphs. But also, as I said, we might get those questions where we want to sub in certain values of x, and that's where we can use that f of -1, f of 0, f of 1. So again, that's a little bit about function notation. So how might we look at some questions with this? So EG4, I think is this EG4 or number 4, should I say? Okay. Now, actually, I'm going to say EG. I'm going to say evaluate or simplify. Given or for f of x equals x plus 2. So I'm telling you that the equation is y equals x plus 2. Remember, f of x is just y. I might even write that above it. Y equals x plus 2. But then it might give you some things to evaluate. For example, f of 3, f of -2, f of 0. Now, what that simply means is, because remember, this is using f of x notation, it's basically saying, instead of putting the x there for x plus 2, can you now replace it with a 3? Can you replace it with a -2? Can you sub in x equals 0? It's basically asking you to sub in those numbers. So, for example, if I put the 3 where the x is, 3 plus 2 is 5. If I put the -2 where the x is, -2 plus 2 equals 0. If I put a 0 in for the x, we get 0 plus 2, which equals 2. We're literally subbing in the x value into that equation. And guess what, gents? That is all function notation is. Now, I could be a little bit trickier, of course, and I could say something like f of q. You might go, what on earth are you doing? Well, instead of having the 0 and subbing it into the x, or the -2 or the 3, I'm simply subbing in the q for the x value, which means I'd have q plus 2. That's why I've said to evaluate, which means to find the number or the value, 502, or simplify, q plus 2. That's done. We could go even more challenging, E, and say f of let's say, a plus 4. So again, if I think about my equation of x plus 2, and for this purpose, I'm going to write x plus 2 down there, what it's saying is, where that x is, can you just simply replace it with an a plus 4? Yeah, all right, I don't really know why I'm doing that, but why not? A plus 4 plus 2. And now what we can do, when we replace the x with the a plus 4, We can now simplify because 4 plus 2 is 6. We get 8 plus 6. And that's my answer. Job done. So again, it's basically just a way to write substitution in a quicker format. Okay, now, of course, depending on what the function is, it can get a little bit more challenging, and it's just the substitution that gets harder. I'm going to, again, for example, 2, write evaluate or simplify. But this time I'm going to give you two different functions. F of x equals a squared, oops, I'm going to say not a, x squared, and g of x equals x plus, actually I'm going to do x minus 5. So this time I'm giving you two different functions, right? And you can clearly see which is which because one's f and one's g. Remember, technically speaking, this just means y equals x squared. This just means y equals x minus 5. That's what it really does mean. But my questions would look like this. Evaluate. I might say f of 3. I might say g of 2. I might say, let's say f of 1 plus g of 1. So again, all this is doing, gents, is asking me to substitute numbers into one of those two equations. So f of 3 means I'm going to that first one, which says x squared. So I'm going to put a 3 in where the x is. And what's 3 squared? Well, 3 squared is 9. Done. If I said g of 2, well, that would be the second equation because that's the g of x, which is x minus 5. So I'm going to write 2 minus 5. And what's 2 take away 5? Well, that's minus 3. Job done. So what do you reckon the last one would mean? F of 1 plus g of 1. Well, f of 1 would be substituting 1 into the first equation, which is 1 squared. You can put brackets, you don't have to if it's not a negative value. Plus g of 1, I'm going to put 1 minus 5. Again, you can put brackets, you don't have to. 1 minus 5. Now, I'm going to simplify. 1 squared is 1. 1 minus 5, that's negative 4. And 1 minus 4, of course, is negative 3. And that's now my value. So it can get confusing, I understand that, but realistically, I think a lot of you will get this pretty fast. It's just another way to write an equation, and it's just telling you what to sub into it. Now, of course, I could make things a little bit nasty. Okay, so if I went nasty, I might say f of x plus 3. Now, that would be a little bit nastier. Okay. Now, what this means is, and I'm going to rewrite my equation, f of x equals x squared, just so I've got it there, right? So what this is asking me to do is to take the x plus 3 and to put it in where the x is. I mean, that's not that nasty, but it is certainly different. Now, if I do that, this is what I get. I'm going to put brackets around it because I'm subbing into it, squared. I mean, that's all I'm actually doing, right? I'm subbing in whatever's in the brackets into the x. Now, of course, we could simplify that by expanding it out. It's a perfect square, so square the first, times them together, 3x, and double it, 6x, and then square the last, which is 9. And that would be my value of f of x plus 3. So it's not overtly easy, but it's also not overtly hard. Okay, again, I could go completely random and do this. This would be a bit random. I'll still use the same 2 there. I could say something like 5 g of x plus 2. Now, this is a bit more random, right? You look at that and go, oh, what are you doing here, Pay? And really, it just says 5 times whatever g of x is, add 2. Well, 5 times g of x, well, g of x we can see is x minus 5. This time I haven't really done anything with g of x, so I haven't like subbed any values into it. So I just had the g of x is negative 5. x minus 5, and plus 2. Let's expand it. 5 times x is 5x. 5 times negative 5 is negative 25 plus 2. We're left out with 5x, and then that will make minus 23, I believe. And that's it. Now, how could I make that a bit different? Well, I could have subbed a number into g of x and said, like, I don't know, 5g of 4, for example, plus 2. Now, all that means, of course, is sub 4 in where the x was. And you could do it at any point. I could do it at the beginning of my question. 4 take away 5, of course. If I did at the beginning of my question, right at the top of that screen, if I could go down, 4 minus 5 is negative 1. I could have said 5 times negative 1 plus 2. That makes negative 5 plus 2 is negative 3. I got my answer there. A bit hard to see in green, isn't it? But I could also expanded it like I already did, and then sub the 4 in. 5 times 4 is 20. 20 minus 3 is minus 3. Didn't really matter where you sub that 4 into it. Okay, again, that negative 1, by the way, came from saying 4 minus 5 was negative 1. Okay, so again, that's just function notations. I'm going to go back over, having a look what we said. A function is simply where you have a set of coordinates where every coordinate only has, or every x coordinate only has one y. But more so a graph, you can see that vertical line test. If it cuts it once only, it's a function. If it cuts it more than once at any point in that graph, we call it just a relation. That's number one. Function, set of coordinates that every x value only has one y value. A relation is a set of any other coordinates. We then looked at function notation, f of x. And remember, when I'm talking about that, I'm going to write down here, we say f of x. That's how the terminology is, f of x. So f of x just means y. They're the same thing, and it just means whatever's in that little bracket part, we can sub into whatever the equation is. So we looked at the f of x equals x plus 2. We subbed in 3, got 5. We subbed in negative 2. We got 0. We subbed in 0. We got 2. I subbed in q. I just got q plus 2. I subbed in a plus 4. I got a plus 4 plus 2, etc. Okay, and that's all we're doing. All right, gents, as I said, it's a bit confusing. Sorry for it's a bit of a lengthy meeting today. Hopefully that kind of makes a little bit of sense to you. 9H, I think I put questions 1, 4, 5, 6, 7, and 12. Hopefully that all makes sense to you. If not, I'll hopefully be in class tomorrow, if not the next day. Have a wonderful day, gents, and I should see you very soon.